Hello guys, this is teacher Jules in Thant. Welcome to Science with Stanley, and today I'm going to discuss about acids, bases and salt preparations, chapter 17 of your IGCSE chemistry. Alright, so since this topic is very wide and very broad, I'll be dividing this chapter into several videos. Now, in this video, we are going to learn about the reaction products between bases and acids. Okay, so since you want to prepare salts, you definitely need to know the equations, how to write equations that involve different bases and acids. Now, first of all, these are some common acids that you should definitely be familiar with at IGCSE level. Hydrochloric acid, nitric acid, sulfuric acid, ethanoic acid, and phosphoric acid. You must know all the formulas of these acids as well, and then the names of the salts that comes from the acid. For example, from hydrochloric acid, we will get chlorides. From nitric acid, we will get nitrates. Sulfuric acid for sulfates. Ethanoic acid will give ethanoates. Okay, so ethanoic acid, you will learn more about this in organic chemistry. And phosphoric acid will produce us phosphates. Now, some common bases include metal oxides, metal hydroxides, or ammonia. Now, these are all bases that you have definitely heard before. For example, sodium oxide, okay, Na2O, potassium hydroxide, KOH, or ammonia, NH3. These are all acids, okay, and the bases below are going to neutralize the acids above in salt preparation. Now, the reaction of acids, okay, so if metals are going to react with acids, we're going to take hydrogen as our point here, and the metals above hydrogens will follow this general formula where a metal will react with acid to produce a salt and hydrogen. For example, let's see, if we want to produce magnesium sulfate salt, MgSO4, the metal that we need to use is of course magnesium, which is a solid, and then acid. Since we want to produce sulfate, the acid would be sulfuric acid, H2SO4. Since this is an acid, it will be aqueous. Will react to give salt is magnesium sulfate, MgSO4 aqueous, plus hydrogen gas, and hydrogen is a gas, of course, okay? So this is simply the reaction equation for metals above hydrogen in the reactivity series. Now, I'm going to write down the ionic equation so that I can explain to you why this is called a displacement reaction. Now, Mg solid, we cannot break it down into any forms because it is simply a solid, so we're just going to write it down as Mg solid. H2SO4, however, can be broken down into 2H plus aqueous plus SO4 2 minus aqueous. Now, there is something that I would like to mention here, okay? So please pay attention. So in exams, most students tend to make the mistake of writing H2 plus aqueous. This is completely wrong because what we are trying to say here is there are two hydrogen ions, but if you write H2 plus, it means that your hydrogen gas has a charge of +1, which is entirely wrong, okay? So that's why please do not make this mistake in your exams. Now, MgSO4 can be broken down into Mg2 plus aqueous plus SO4 2 minus aqueous, and hydrogen gas will simply be hydrogen gas. In exams, if you have solid, liquid, or gases, know that you cannot break them down into positive ions and negative, let's say, okay, not OH, okay? It could be anything. Y minus ions, you can simply break them down into this like I would do for sulfuric acid aqueous, okay? Although they may be, you cannot write it down at all. Alright, so we're going to remove our spectator ions, which are present on both sides of the equation. So I'm going to remove SO42 minus and SO42 minus. So my final net equation, I would be left with magnesium solid plus 2H plus aqueous will react to give Mg2 plus aqueous plus H2 gas. Now, in order to make sure that your equation is right, you should always balance your equation or check if your equation is balanced. I have 1 Mg. I have 2 hydrogen. I have 2 hydrogen. I have a charge of 2 multiplied with 1, so this is plus 2. And on the right side, I have plus 2 as well. So I know that I have the correct ionic equation. Alright. So in the same way, you can try out for other salts as well that you would like to try. For example, let's say you want to try zinc chloride. It will be ZnCO2. You can start with the metal zinc and have a hydrochloric acid and get your zinc chloride and hydrogen. Okay, but this equation, this general equation, is true only for the metals above hydrogen in the reactivity series. Now, for metals below the reactivity series, they will undergo a neutralization reaction. I will get to it in a minute, but essentially they will follow this general equation. But I would like to tell why it is different as well. Because when metals are above hydrogen in the reactivity series, they have high reactive power, or they are highly reactive. But metals below the reactivity series, they have very low reactivity, meaning that they will not easily react with acids in the same manner as these metals will. Okay? So that's why if we want to produce a copper-2 sulfate salt, we cannot simply write copper plus sulfuric acid will produce copper-2 sulfate and water. We simply cannot write this at all because copper is not going to react with sulfuric acid. This is wrong. So instead, for metals below hydrogen, we need to find an oxide of those metals. For example, copper will have copper-2 oxide, which is CuO. Okay, so CuO, copper-2 oxide, is a solid. Sulfuric acid is aqueous. The copper-2 sulfate that we will get will be also aqueous, which is a blue solution, and water will be liquid. Okay, so this is why is this called a neutralization reaction? It is because the O2 minus from copper-2 oxide will neutralize H plus ions from sulfuric acid in order to form H2O, water. Now, since you have to balance equations, you have to multiply H plus with 2. So you have a total charge of 0 on the left side because 2 minus plus 2 plus is equal to 0. You have 0 on the right side. And this is called a neutralization reaction. So let me go back again. In the exam, you need to be able to explain why your equation is a neutralization reaction or a displacement reaction. And since we are here already, I would like to mention one thing again. So whenever hydrogen gas is produced in your chemical reaction or an equation, what you should know as your observation is that there would be fizzing or bubbling. Okay, so these are the two words that you can write for your observations: fizzing or bubbling. And hydrogen is also a colorless gas that you will see that comes out of the reaction. And in the next few chapters, you might learn how to test for hydrogen gas. We call it a squeaky pop test, where you try to light up the hydrogen gas is coming out in order to see if the gas is really hydrogen or not. But that is for a later chapter. Now, reaction between metal hydroxides and acids. Okay, so metal hydroxide is also a base as well, so it will react with acid to produce salt and water. For example, let's say, what is a metal hydroxide that you can think of? Let's say sodium hydroxide. So sodium hydroxide, NaOH, aqueous, will react with, let's say, phosphoric acid, H3PO4 aqueous, to produce a salt. So what salt will we produce? Sodium phosphate. Na3PO4 aqueous plus water, which is a liquid. Okay, and this is also a neutralization reaction because the base, or the OH minus from sodium hydroxide, has neutralized the H plus ions from H3PO4 in order to form water, which is a liquid. Okay, and you should know how to balance this equation by yourself. So reaction between metal carbonates and acids. Now the only difference here is that since we have a carbonate here, you're going to have carbon dioxide on this side as well. So let's use the same example. Sodium carbonate, Na2CO3 plus, let's say, sulfuric acid. Or let's try writing nitric acid this time. Okay, so we will produce what salt here? Sodium nitrate, which is NaNO3 plus water, and finally we would have carbon dioxide. Students tend to forget to write carbon dioxide when it involves carbonate, but since we have carbonate, we are always going to produce carbon dioxide. All right, so in the same way, we can see in this equation that since carbon dioxide is produced, we will have a very milky solution. Okay, it won't be very clear like normal solutions would be. Okay, so let's try to write down our net ionic equation here as well. Okay, so sodium carbonate can be broken down into 2Na plus CO3 2 minus. And remember that if I'm not writing down any states, it's because they are aqueous. Okay, so HNO3 would be H plus plus NO3 minus. Sodium nitrate would be Na plus plus NO3 minus. And we would have H2O plus CO2. Because why? Water is a liquid and carbon dioxide is a gas. But we should balance the equation before writing our ionic, so I'm going to write it back. So 2Na, we would have 2NaNO3, and since we have two pairs of NO3, we can multiply here as well. So let's see, Na2, Na2, CO3, C, and O is. Alright, so we have a balanced equation here already. Alright, so let's try to put them down here as well. So it's going to be 2H plus plus 2NO3 minus 2Na plus plus 2NO3 minus. Okay, and here's a thing as well that students often tend to make mistakes. If it is HNO3, it will be broken down into H plus and NO3 minus. But after you balance the equation, you might have a number in front of HNO3, and you will also have to count those numbers as well if you want to write your full ionic equation. All right? Okay. So let's remove the spectator ions as usual. So we will be removing 2 Na plus. We will be removing 2 NO3 minus and 2 NO3 minus. So the ionic equation that we are left with is 2H plus aqueous plus CO3 2 minus aqueous will give us water, liquid, and carbon dioxide gas. Alright, so again, balance your equation as well. 2 hydrogen, 3 oxygen, 3 oxygen, 1 carbon, 1 carbon. The total charge on the left side is plus 2 and minus 2, so 0. The total charge on the right side is 0. This is a neutralization reaction because the CO3 2 minus ions from Na2CO3, CO3 2 minus ions from Na2CO3 has neutralized the H plus ions from HNO3. Now, to summarize the reactions between bases and acids, we have 4 equations. For metals above hydrogen in the reactivity series, we will use the first equation. For metals above the hydrogen, we will use this equation. And if the metals are below the reactivity series, they have very, very low reactivity. That's why we need to find an oxide for them. And for the third and fourth, it is essentially the same, but the fourth equation, you have to take care of the fact that since we have carbonate, we are going to produce carbon dioxide. Okay, so I'm just going to write down some very rough ideas on equation. Let's say lithium plus hydrochloric acid will give me lithium chloride plus hydrogen gas. So if it was metal oxide, let's say silver oxide, and if I want to produce silver sulfate, it would be H2SO4, and my salt would be silver 2 sulfate and water. If I have a metal hydroxide, let's pick one, let's say magnesium hydroxide. Magnesium hydroxide, MgOH twice, plus let's say an acid, nitric acid, HNO3. Okay, so we will have what acid? We will have magnesium nitrate, MgNO3 twice, plus water. Now, if we have a metal carbonate, let's say copper 2 carbonate, plus if we want to produce a copper 2 sulfate salt, what acid do we need? We need sulfuric acid. So it will produce copper 2 sulfate plus water plus carbon dioxide. Okay, so you should know that only this is the displacement reaction, because here your metal is above hydrogen in the reactivity series. So that's why the lithium was able to displace hydrogen ions from hydrochloric acid. For the metal oxide here, this is a neutralization reaction because the O2 minus ions from metal oxide neutralizes the H plus ions or hydrogen ions from sulfuric acid to form water. In here, this is also a displacement reaction because the OH minus or the hydroxide ions from your metal hydroxide neutralizes the H plus ions from your acid to form water. Sorry, this is a neutralization reaction. Okay, last thing is also the same. This is also a neutralization reaction because your carbonate ions from CuCO3 has neutralized the H plus ions from sulfuric acid to form water and carbon dioxide. So that is all for today's lesson, and let's try to practice some equation between bases and acids, because in exam they won't be telling you step by step. You will need to be able to write these on command. Okay, so let's say magnesium plus sulfuric acid, right? Since this is a metal above hydrogen in the reactivity series, we can simply write magnesium plus sulfuric acid will give magnesium sulfate and hydrogen. Zinc plus hydrochloric acid will give us zinc chloride plus hydrogen. Now lithium hydroxide and nitric acid will give us LiOH plus HNO3. Since this is a metal hydroxide, instead of a hydrogen, we will have water. Okay, so this will be LiNO3 plus H2O. Zinc plus nitric acid will be similar to this one. Zinc plus nitric acid will react to give zinc nitrate plus hydrogen. Now magnesium carbonate plus hydrochloric acid, MgCO3 plus HCl, it will give us magnesium chloride plus water plus carbon dioxide. Now iron plus sulfuric acid. By now you should know how all of these equation works. Okay, so we will have iron 2 sulfate FeSO4 plus hydrogen H2. Zinc oxide plus hydrochloric acid will give us what? Zinc chloride plus water. Finally, iron 3 oxide, so it is Fe2O3 plus sulfuric acid will give us what? It will give us Fe2SO4 thrice plus salt plus what do we get? Water. Okay, so try to practice this equation and any base acid equation that you can find until you can write all of these equations at your will. Alright, so that is all for today, and I'll see you in part 2 of chapter 17.